resistance, series and parallel arrangement of resistors and application. Current electricity. Subtopics: Ohm's law, resistance, series and parallel arrangement of resistors and application of resistance.
Introduction. In Form 1, we discussed about an electric current, a bulb, a dry cell, a switch, circuit symbols, and simple circuits. We learned circuit symbols like for a bulb, a switch, a voltmeter, an ammeter, a fixed resistor, a variable resistor, among others. Construct a simple circuit which has a bulb, connecting leads, a voltmeter, an ammeter, a switch, and cells by dragging and dropping. See the circuit components which are supposed to be dragged and dropped in their right positions. Ohm's law. When potential difference is created across a conductor, current will flow. It is therefore important to determine how the two variables relate. To understand this relationship, do the following. Note the initial reading by the ammeter and corresponding reading on the voltmeter. Then adjust the rheostat by either increasing or decreasing the resistance using the play button provided to obtain 5 pairs of the current and voltage readings. Plot a graph of voltage V against current I. Observations. The graph obtained is a straight line graph passing through the origin. Discussion. A graph of voltage against current is a straight line passing through the origin. This shows that voltage is directly proportional to current, hence V is equal to IR. The gradient of such a graph gives resistance R. Conclusion. The relationship between voltage and current is known as Ohm's law, and it states that current flowing through a conductor is directly proportional to the voltage across it, provided temperature and other physical factors remain constant. The relationship, that is Ohm's law, can be expressed as V is directly proportional to current, which is further expressed as V is equal to constant multiplied by I. The value of the constant is the resistance R of the material.
Resistance. The collision between electrons and atoms hindering the movement of the electron is called resistance. Resistance is the opposition to the flow of an electric current, and its SI unit is the ohm. Play the animation below to see how this happens.
Arrangement of resistors. The way resistors are arranged will affect the amount of current flowing in a given circuit and the voltage across any 2 points. In case of a bulb, it can affect its brightness. Resistors are either connected in series and in parallel. Click on the play button to observe these two possible arrangements. Observations. We have observed that for 3 resistors in parallel connection, the brightness of the bulb is more than in a single resistor and the brightest for 3 resistors in parallel. The bulb is bright for resistors in series, brighter for a single resistor, and brightest for resistors in parallel.
Series arrangement of resistors. The illustration below shows a series connection of resistors. Click on the word series to observe a series arrangement of resistors. Parallel arrangement of resistors. The illustration below shows a parallel connection of resistors. Click on the word parallel to observe a parallel arrangement of resistors.
Derivation of formula for effective resistance. Series arrangement. Before we start deriving the formula for effective resistance for this case, it is worth noting that current is constant throughout the circuit. From V is equal to V1 plus V2, but V1 is equal to IR1 and V2 is equal to IR2. Hence, IRT is equal to IR1 plus IR2. IR parallel arrangement. In parallel arrangement, the voltage across each resistor is the same. From Ohm's law, V is equal to IR. Therefore, I is equal to V divided by R when current I is made the subject of the formula. Hence, Vt divided by RT is equal to Vt divided by R1 plus Vt divided by R2. Vt divided by RT is equal to Vt in brackets 1 divided by R1 plus 1 divided by R2. Total voltage can be factored outside the brackets, and then the equation is divided by Vt on both situations, hence simplified as 1 divided by RT is equal to 1 divided by R1 plus 1 divided by R2. If the resistors are 3, 1 divided by RT is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. If we have n resistors, then I divided by RT is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by Rn. In general, the total resistance for resistors in series is the sum of all the resistors.
Application of resistors. There are several day-to-day applications of resistors and resistance. As we learned previously, resistors are used to regulate the amount of current. Different electronic and electrical gadgets require different types and sizes of resistors. The following are some of the common applications.
Fuse. The fuse is used in most household electrical gadgets such as electric iron boxes, sockets, among others, to regulate the amount of maximum current permissible in the respective gadget. To understand how the fuse protects these devices, close the switch and vary current such that it rises beyond 5 amperes as you observe the bulb. What happens? Click the play buttons provided and make your observations.
Observations. The fuse blows when the current exceeds 5 amperes. Explanation. When current passes through a thin resistor as the fuse, the temperature rises and melts the wire, hence disconnecting the circuit and no current flows. Therefore, a fuse is a thin wire with low melting point which breaks the circuit to protect devices from high currents which could be destructive to the device.
Arrangement of bulbs and fluorescent tubes. Another common application of resistance is in the arrangement of lights in houses, offices, and other places. Bulbs and fluorescent tubes are normally arranged in parallel so as to ensure equal voltage and maximum lighting across them. Potentiometer. A potentiometer is commonly used in most household devices such as radios, television sets, among others. This is a device that regulates resistance, hence the amount of current flowing in a radio can be regulated using it. Click on the play button to make your observations.
Niaje Alande hapa Meru tuko point kabisa na wale samana nikiwa na akina nani ukisema na mabeste zetu unasema watu wote wa Samburu